Jai Shri Gurudev. Our next lecturer video is problem number 3. A crane hook of trapezoidal cross section with an inner side of 120 mm and outer side of 60 mm. The depth of the section is 90 mm. The center of curvature is at a distance of 120 mm from the inner edge of the section, and the line of action of load is at a distance of 135 mm from the inner edge. Determine safe load that the hook can carry if it is made of steel having an allowable stress of 90 MPa. Now read the problem once or twice. Now identify the type of C frame it is. This type of curved beam it is a crane hook of what type of cross section it is? Trapezoidal cross section. Now how you know the trapezoidal cross section? This is a trapezoidal cross section. This is a crane hook and this is a trapezoidal cross section with an inner side of the 120 mm. The inner side is how much? 120 mm, and outer side is the 60 mm. The depth of the section is 90 mm. The center of curvature is at a distance of 120 mm from the inner edge of the section. As you know, this is the crane hook, this is the inner surface, this is the outer surface. From the inner surface, what is the center line of curvature is? From the inner surface is a distance of 120 mm, and the line of action of the load is at a distance of 135 mm from the inner edge. From the inner edge, how much is 135 mm, that you can see here. From inner surface to the line of action of force is at 135 mm from the inner edge. Determine the safe load, the F you want to calculate, that can carry if it is made of steel having allowable stress. The crane hook is made of steel, is allowable stress is how much? 90 MPa. Now read the problem, then write the appropriate sketch of crane hook and its cross section with the notation. Right, now due to this load F is acting, that produces a bending moment. Okay, then write the centroidal axis and neutral axis. Now above the neutral axis the fiber undergo compression, below the neutral axis fiber undergoes tension. Then again redraw the sketch below this, redraw the sketch and with notations you all find, you all redraw the sketch and with notation you mark it, you write it. Then after that write the given data. The given data is a what type of curved beam is a crane hook of trapezoidal cross section, and write the given data. From by seeing the figure and the given data, write the given datas. Now the allowable stress is nothing but what is a maximum stress. Now from the figure you can calculate R naught also. Now let's compare this problem with the previous problem. In the previous two problems we determined only stresses induced in the curved beam by giving all the data, cross-sectional data, load, there's a sectional properties, then loading properties are given. But here loading property is not given. That is the first ultimate aim, to determine the loading property. Then determine the stresses induced in this. Or what another additional data is given? Maximum stresses induced in the beam is given. Right, now how to solve this problem? Now once you write the given data, then you go write the other data. What are the other data? By referring table 2.7 for trapezoidal cross section, again one more time write the cross section, trapezoidal section with their notations. Here the notations are different here, and upper side is a B, in from this is a B0 by 2, B0 by 2. You know that this is inner surface, always inner surface is the higher larger dimension and outer surface is the lesser dimension. Now the data is given, then write that according to the sketch, write the data. B is 60 mm is given, then from B0 by 2 plus B0 by 2, that enter it is how much, 120 mm. From this you calculate B0. And H is given, sorry, here H is not 60 mm, it is 90 mm, 90 mm. Then calculate according to the table 2.7 for trapezoidal cross section. A is given, the formula is given, now substitute, then you'll get the values. The cross sectional value is 8100 Newton per mm square. Then C, farthest distance. Here the C is given from outer fiber. In the sketch it's given. C is from outer fiber. C is nothing but, C is the central axis. Distance from outer fiber to the central axis, that we call, that is C. Then substitute the values, we'll get 50 mm. The C is nothing but what, C to here, that is 50 mm. Then calculate C1, and then once you calculate C1 and C2, then calculate RC. As you know that RC is equal to RA plus C1. Now this is the RC value. After calculating RC, then other data, again by referring table 25.2 for trapezoidal cross section, use this equation, then calculate the neutral axis radius, right, radius of the neutral axis. Again H already we know that Bi B0 is given, H is given, Bi B0 is given, right. Then Ri also you know the substitute, then we'll get Rn is equal to 156 mm. As in, how to verify, always the radius of neutral axis is less than the radius of the centroidal axis. Once you calculate Rn value, then you can immediately calculate Ci and C0, distance from neutral axis to inner fiber, distance from neutral axis to the outer fiber. Ci C0 are this value 36 mm and 54 mm. Then calculate eccentricity, the distance between central axis and the neutral axis. Then L, the distance between the line of action of force and the centroidal axis is given is a for inner radius, inner surface to the line of action of force is 135 mm plus C1, will get 175 mm. F is unknown. Then what is the moment is force into distance. Due to the F is acting on the crane hook, will get, due to F is acting on the crane hook is vertically downward. Due to that, this eccentric load from the centroidal axis, there are two types of stresses developed. One is direct stress, another one is bending stress due to bending moment, force into distance, right. Now we calculate, first we calculate direct stress, F by A. F is unknown, keep it as it is, the tensile stress. Then another one is bending stress at inner fiber. By referring the data handbook 25.22, the inner fiber undergoes tension, right. Then substitute the value of FB in terms of MB in terms of F. A you know that, E also we know that, Ci Ra already we calculated. Then substitute this is a value. Then is given one condition is given. What is the condition? We know that the maximum tensile stress is at inner fiber, right. We know the combined stress is nothing but sum of direct stress and bending stress. Maximum tensile stress is at inner fiber. We know that combined stress at inner fiber is sigma Ri is equal to sigma D plus sigma Bi. Take sigma Ri, the maximum maximum tensile stress in the fiber. The combined stress at inner fiber is nothing but maximum stress is induced, that is 90 Newton per mm square is given. Then so substitute the value, then we'll get F is equal to 51.61 Newton is a tensile, right. Next, similarly go for bending stress at outer fiber is a compressive nature. Then use this equation 25.54, negative sign shows compressive nature. Now substitute, we'll get sigma B0 in terms of F. We know that maximum compressive stress is at outer fiber. The combined stress at outer fiber is sigma R0 is equal to sigma D plus sigma B0. Now we take here what is the maximum, the combined stress is nothing but at outer fiber is equal to sigma max 90 Newton per mm square. Now back substitute, Then simplify it. Finally, you get F is equal to 71.11. Negative sign shows compressive nature. Out of these two forces, which force you will consider? Always choose the lesser value of force. There's a select the smaller value of force that has to safe load and maximum capacity the crane can withstand this load. 51.61 to 51.61 kilo Newton. Right, for in compared to dimensions, if you for compare comes to dimension, take larger value of dimension. When it comes to force, take lesser value of forces. Right, and one more here, the maximum in this problem, the maximum stress is given. Right, maximum stress is given or allowable stress is given. In some problem, instead of allowable stress, they'll give the factor of safety and the metal is given. As you know, the factor of safety is equal to failure stress by allowable stress, or nothing but working stress, that is equal to failure stress may be heat stress or ultimate stress. Take the data from the volume 1, right, in chapter 1, then substitute, then you get allowable stress that considers the maximum stress. Yes, thank you for watching this video.